Motorcycle line geometry. But let me explain. I'll be describing the usable area of the road. This is a road with a lane in both directions. I'm sure many of you have years of riding experience. You may even ride better than me. You can decide on safety margins to suit your tastes. Some people drive 6/10 or 8/10 or 10/10. When you are trying something new, take it easy until you have demonstrated that it is working. Unless you are sliding the tires, which is way too fast for public roads, you can take the same line at any speed. In reality, motorcycles are dangerous. Not riding is the only safe thing. Barring that, be sensible. I'll only be showing the usable area of the road from now on. The constant radius turn has an entry straightaway that connects to part of the circular arc connected to an exit straightaway. If you extend the outside straightaway edges to over the curve, they will intersect. You could call this the straightaway intersection. B is the number of degrees you will be turning. You want to create a line that is an angle bisector. You do this just like in 5th grade. Put the point of a compass at the straightaway intersection. Mark off equal lengths on the entry and exit lines. Go to these 2 points and mark off an arc about where the center of the angle is. Where the last 2 arcs cross is the center of the angle. Draw a line from the straightaway intersection to the cross. Triangle DEF equals triangle DEF. Angle A equals angle A. If you fit a circle that touches the entry and exit lines in the center of the curve, the center of the circle will be on this line. You are guaranteed to hit the corner entry and corner exit with a circle by construction. Adjust the size and center of the circle to also hit the apex. This saves a lot of guessing. This is the largest circular path you can put through the usable area. It is much larger than the radius of the curvature of the road. I'm sure everyone knows outside, inside, outside. It's a bit difficult to indicate speed, so I will indicate equal increments of time between lines, roughly perpendicular to the path of travel. At a constant speed, the lines will be equidistant. If the lines are getting closer together, you are slowing down. If the lines are getting further apart, you are speeding up. Let's remove the clutter for a moment and look at the path we have constructed. Constant speed turns. Another well-known phrase is, go deep, turn hard. You want to get from upright to fully leaned over quickly at the corner entry. You want to get from leaned over to upright quickly at the corner exit. Counter steering helps. Position, speed, lean angle. When the lines get closer, you are slowing down. If you are lazy about entering the corner, you can early apex the corner and run wide at the exit. The faster you go, the more important it is to hit your corner entry position precisely. Simpler picture. You can be a half second early or late hitting the corner turn in when you have a big safety margin. You have to be on time when you run the safety margin down to 0, as at a racetrack. Plan your corner your plan. If you are correcting your way through the corner, you are not cornering your plan. Of course, make corrections as necessary. Let's look at a decreasing radius turn. There are 3 techniques for handling a decreasing radius turn. You can late apex the turn, you can decrease speed throughout the turn and turn harder toward the exit. You can progressively increase lean angle so that you are turning harder where the radius is getting smaller. You can combine any or all 3 together. Most of you already have this nailed, but I'll go over it slowly for the newbies. We all had to start somewhere. Will our angle bisector method work on non-circular arc curves? Yes, it will if a circle can be inscribed in the usable area. Note that we have a late apex. It is not in the geometric center of the turn. Hence the phrase, late apex decreasing radius turns. Or you can decrease your speed, trail brake, and turn harder throughout the corner. Or you can progressively lean the motorcycle as you go through the turn. Increasing radius turns are like coming back the other way. You can early apex, you can increase your speed, which will cause you to run wide in a constant radius turn, and you can reduce your lean angle and turn less. You always have control over position, speed, and lean angle. Early apex and increasing radius turn. Increase your speed to increase your radius. The bike has a tendency to stand up as you accelerate. You can also simply decrease your lean angle as the turn widens. Early apex and increased speed and decreasing lean angle is the most popular method. Decreasing radius in, increasing radius out turns. The majority of turns are built this way. Road builders assume you won't slide in until you feel the centrifugal force. The apex ends up more or less in the center of the turn. The traction circle. This shows combinations of the front to back and side to side forces that add up to 100%. The dots on circumference are 100%. Note that the vector sum is less than the algebraic sum. You can simultaneously have 86.6% of the maximum acceleration force and 50% of the maximum centrifugal force. In racing, where 1% advantage is huge, this is just too good to pass up. Hitting the corner exit with an extra 5 to 10 miles per hour speed means you can carry the extra speed all the way down the following straight. I redrew the racing line about 10 times, but I'm pretty happy with this one. Compare it to the circular arc line. I'm certainly willing to believe there are other possibilities. A new very important position is introduced, the point of slowest speed and hardest turning. Make this part of your position plan when trail braking in and accelerating out. Understanding force is essential to understanding motorcycle riding. Stay in school and take those algebra and calculus courses. It will be worth it. Real-world examples of force. The coefficient of friction tells you when your tires will start sliding. It is the ratio of the force in the plane of the road to the normal force. The coefficient of friction changes depending on temperature, heat cycle, tread wear, and a bunch of other factors. It is still a useful tool for analysis, but it is not a fundamental theory like centrifugal force. Your motorcycle tire has a conic cross section and turns like a rolling cone with camber thrust. Uphill, downhill, braking and accelerating change the normal force on the front and back tires independently. You can decompose a force vector into two force vectors with angles of your choosing, or combine two force vectors acting through a common point into one. We show vectors adding heel to toe, but they are always centered at the origin, usually the contact patch of the tire. I always laugh at people who say, just do this in a corner. You have to figure out each one separately, or sequence of turns if they are close together. You have to take into account the road conditions, radius, camber, elevation, and traction. Braking marker, corner turn-in, point of lowest speed / tighter turning, apex, corner exit are 5 positions that are part of your corner plan. Pop quiz. Remember to wave when you see me coming the other way.